Thank you, everyone, for joining us for their annual Charles R. Catholi Distinguished Dissertation Award and Janet L. Norwood Outstanding Woman in Statistics Award. This is a great turnout. I'm so happy that so many of our former Catholi Award winners and former students are in attendance today. It's a very special year, sad but special. And I would just want to take an opportunity to thank everyone for taking time out of their Friday morning to join us. So the order of events this morning, I will welcome you. That is happening as we speak. We will then spend a few moments to remember Dr. Catholi. Stacy Cofield will then come up and present the Catholi Distinguished Dissertation Award. Then we will proceed into the Janet L. Norwood ceremony and our talk with Dr. Doe, our Norwood Award recipient today. So moving right in, we want to remember Dr. Catholi. Just to sort of lay the groundwork for what exactly Dr. Catholi did at UAB. He joined UAB in 1970 as an assistant professor of biomathematics. In 1977, the year I was born, he became associate professor of biomathematics, professor of biostatistics in 1995. Then from 97 to 99, he was the interim chair for the Department of Biostatistics. And then in 2003, he became professor emeritus. He had achieved the highest rank that a faculty member could ever achieve before I finished my dissertation. So quite the accomplishment and lengthy career. He was here before the formation of the Department of Biostatistics. He witnessed the early days of UAB. He had a wealth of historical knowledge about the school, the department, the university as a whole, and he was very committed to documenting this history and sharing it with all of us. So he was, whenever we went down, metrics, measuring accomplishments of a faculty member, he was never one that really appreciated this. So I'm going to take the liberty to sing his accomplishments. Leadership roles. He had over 18 leadership and support roles at UAB. Some of these included chairing search committees, chairing the School of Public Health Advisory Committee on Information Technology, chairing the Office of Information Management and Instruction Steering Committee, chairing the Biostat Curriculum Review Committee. He also served as an NSF grant reviewer, reviewed for journals as diverse as Statistics and Medicine, Computing Reviews, Journal of Computational Physics, just a wide variety of responsibilities that he had over the course of his career. Education-wise, which is how many of us grew to know him, he taught 19 courses, different courses, some of these multiple times between 1970 and 2023. This portfolio, if you look at his CV, included everything from differential equations, numerical analysis 1 and 2, applied matrix analysis, probability theory, inference, nonparametrics, nonlinear data analysis, sampling theory, advanced inference, stochastic modeling, computer architecture, and mathematical structures for computer science. He was also a resident information technology expert. So if you had an issue with your computer, he was the person to go to. He was a member, as you see here, or not a member, he chaired 9 master's committees and 4 doctoral dissertation committees, but he was also a member of 70 master's committees and 40 doctoral committees over the course of his career. He reviewed for journals, also varying in variety from Statistical Simulation and Computation, Biomedical Engineering, and Journal of Applied Statistics, but he also reviewed for clinical journals such as Stroke and the Annals of Neurology. In terms of publications and his literary accomplishments, His CV lists 80 papers, but I looked him up on Scopus and he had over 100. Again, he wasn't one for metrics, but his H index was 37. So something to be very proud of. He's like I mentioned, great computer expert, published a software package. His Fortran skills were amazing. Published 2 technical reports, 10 abstracts, and over 40 presentations. Recently, we were able to get all of the most recent chairs of the department together for a photograph. This is something we have proudly displayed in the department, and we're very, very happy that everyone was able to be there on that beautiful day. So just chronologically going through time, from 82 to 97, Al Bartolucci served as chair. As I mentioned a few moments ago, Charles was the interim chair from 97 to 99. Then George Howard came, was the chair for a long time from 99 to 2011. After George stepped down, Naomi Feinberg was our chair. And then David Redden from 2014 to 17 did his first tour of duty as our chair. Then Lloyd was our chair from 17 to 19. David, second tour of duty, started in 2019, and then I took over in 2022. Okay. So I'm going to turn over some of the speaking duties now. David, do you mind to share a story about Dr. Catholi?
Good morning. I am truly honored and a little bit overwhelmed at this opportunity to share some thoughts and remembrances of Charles Catholi, known as Chuck to a lot of you. So we'll spend a few moments talking about my relationship with him. I came to UAB in November of 1974. Were your parents born then? 1974. I just finished a master's of statistics at North Carolina State, and I wanted to move into biostatistics. I wanted to learn about patient data, how to analyze patient data. So I came here to the Department of Biostatistics, and it was exactly what I needed. It was perfect for me. So I met Chuck then. He was on my graduate committee. And then after I finished my degree, I moved over to the Division of Cardiothoracic Surgery. And there I was able to work with Dr. Catholi a lot as we were developing a parametric survival version of Cox regression, Cox proportional regression. We worked on that for years. Dr. Catholi helped us. As you know, it's just downright insulting to call him a programmer. That's just not right. He was a mathematician. He knew how to program optimizing algorithms. He was really something. So we worked with him through the 80s, and we did indeed get a pretty nice SAS compatible program that we used for years. I'm laughing because I submitted some slides, so I'm kind of old school, so I appreciate the adaptation. So I've never seen this slide before, but it is the same information. It is the same. So interacting with Dr. Catholi, looking backwards, I realized that there were some common threads. The first thing was the realization that he was an extremely intelligent and knowledgeable professor. But if you interacted with him, and I know a lot of you did, he was never condescending. It was very clear that he was an order of magnitude above you, I mean, without a doubt, but he was never condescending. In fact, I can say he always treated me with intellectual respect, even though I don't think I always deserved it, but he did that. Every interaction, I always learned something, and whatever the issue was that I brought to him, he either gave me the answer or he gave me a direction to go. So he was really incredible and extremely helpful that way. I mean, really, this is funny. What a pretty slide. Mine must have been so ugly, you couldn't even handle it. I tell my children, that I use PowerPoint and they just laugh at me. PowerPoint, really? Yeah. So my graduate committee for my PhD consisted of Dr. Ed Bradley, who's chair. He was literally the best statistician I ever came across. Dr. Eugene Blackstone is an MD, and he worked in the Division of Cardiothoracic Surgery with Dr. John Kirkland, and they hired me after I finished. David Hurst was chair of biostat at the time. Malcolm Turner became chair of biomathematics, and then I had Charles Catholi to always giving support and help, which I needed. So I had literally a dream team of a committee those many years ago. Now, I'm going to talk to you about something that I don't think I've ever discussed in my life with anybody. So I'd appreciate it if you'll keep this in the room. Okay, so I had my written exam in October of 1976. The deal was then you'd take the exam home. You could use any resource, no AI, no internet. Resource meant a book or a journal, and you weren't supposed to talk to anybody. So like, who would you talk to about inverting a matrix? So this is actually a copy of what I handed back. Biostatistics was so proud of that cover. I thought it was pretty cool. Okay, so each committee member was supposed to submit 2 or more questions. My task was that I had to answer at least 1 from each committee member and then another 3. So they didn't tell me who submitted what, but if you knew Chuck, you'd totally recognize this. Now, I know you probably can't read it. I usually apologize for that, but I don't this time, because if you could read it, you wouldn't understand it, except maybe some of you. So it's kind of cool. So the first question, given an, I'm not going to read it all, given an M by N matrix, an M vector, describe, have a least square solution, and it goes on and on. I remember vividly when I read this question, I said to myself, move to the next question. So here was the next, yeah, so I'll back up. So here's the next question, and it just goes on and on and on. The good news was that it asked me to use a SAS proc matrix. So I said, okay, get me in a computer. We might be able to survive this. So I answered a set of questions best I could. I just looked at it this morning. I actually had 10 pages of an answer. I'm very impressed by the 24-year-old David. Then I couldn't do it today. Okay, so I turned in my exam, and then the deal was 2 weeks later, there would be a written, an oral exam. And I think regardless of whether you did well on the written, they were going to have an oral, either to make sure you knew that you didn't know anything, or maybe to move you along. So 2 weeks later, oral exam. So I went to Dr. Catholi's office in preparation, and I said, Dr. Catholi, I was wondering if you would be willing to give me a clue as to what you would ask. He said, close the door, David. I closed the door, and he said, absolutely. He said, I submitted 2 questions to the written. You blew off the first one. I'm going to ask you that in the oral. And he said, I'm guessing the other committee members are going to do the same thing. I'm thinking, oh, goodness. He said, now, David, he said, I don't plan to tell your other committee members about this discussion. I'm guessing you won't either. I said, no, I'm not saying a word. So I said, thank you. And I left, and I prepared, and I prepared, and I prepared, not just preparing the answer, but the delivery. I wanted it to look like I was thinking on my feet. And in an oral exam, you always want to burn up time, bore the committee. So man, I was going to burn up time. I worked on the other people's questions, but his, I was so ready. Wonder what the next slide will be. Okay, oral qualifying. Okay, so it's time for the exam. Got my new 3-piece suit on. I'm so ready. So Dr. Bradley, the head of the committee, He says, we'll now begin the oral exam for Mr. David Nafta. We'll start on my right and go around the table for questions. Chuck was on his right, Dr. Catholi to me. I said, oh man, this is so good. So I'm thinking, complete joy. I had no guilt over this conspiracy. Okay, let's get started. So Dr. Catholi, he looked at me, he smiled, and he said, I have no question. Obviously, I've never forgotten or recovered from that. But I will tell you, as memorable as that was, 2 years later, when I had the defense of my dissertation and it was successful, as we were walking out the room, I said, thank you, Dr. Catholi. And he said, call me Chuck. So that's how I remember him. He's literally one of the most important men ever in my life, personal, especially professional. So thank you for letting me share some of that.
Good morning, everyone. So my name is Dr. Stacey Cofield. I'm professor in the department, vice chair for education, and I am honored enough to read a statement from Hong Gao, Dr. Hong Gao. Here he is pictured with Chuck in 2010. And the statement reads, I want to share some of my fondest memories of Chuck. When I was at UAB, even after more than 10 years of getting my PhD, calling him Chuck instead of Dr. Catholi still does not feel quite right. His extensive knowledge of statistics, his genuine care for his students, and his generosity in sharing his time and wisdom with people around him inspire me to this day. I draw from his legacy in how I interact with junior fellows and other colleagues in my career at the CDC. My conversations at that time with Chuck often jumped from topic to topic. We would discuss the one-child policy and how the Chinese government enforced it, then the topic of circuit boards, and finally the topic of Fortran coding, my first programming language, and pool screening. He could code in Fortran faster than writing his own name, and pool screening was his field. My classmates and I quickly discovered that once he started talking about pool screening, he would become so passionate that he could not stop, whether he was in the classroom or his office. Naturally, several of us were intrigued enough to choose pool screening as our dissertation topic. When I was working on the second paper of my dissertation, I could not find a way to mathematically prove the simulated results. Dr. Catholi patiently waited, and perhaps after seeing I had struggled enough, one day he emailed me the proof of the needed theorem, which became the foundation of our second paper we finally published in the Journal of Communication and Statistics. Without any doubt, his kindness and support helped me to graduate sooner. Like Dr. Catholi's other students, I was extremely fortunate to have him as my advisor and mentor. He truly exemplified and embodied what it means to be an educator. Our memories of his love for teaching, his care for his students and others, his sense of humor, and his radiant smile will always live on. Me and my family will forever be indebted to Dr. Catholi. Yes, very beautiful. Boyi Guo could not join us today, but has sent a video.
My name is Boyi Guo. I'm an alumni of the department and a past awardee of Dr. Catholi Distinguished Dissertation Award. I deeply regret that I cannot be there in person to celebrate the life of Dr. Catholi with y'all, but I wish to share with you my fond memory of him. To me, Dr. Catholi was a teacher who cared deeply about his students, not just about their grades, but about their growth and success as individuals. I had the privilege of taking one of his class during my PhD program, the Advanced Inference. For people who had known me, I'm an inquisitive person, to say the least. Starting teaching myself, I realized it was a misfortune for anyone who had me in their class, especially for one of the most theoretical classes. Dr. Catholi made the job look effortless. He answered my millions of questions on the spot and guided me to think deeper about ways to connect what we learned to my own research. It would not be possible for anyone who doesn't have decades of experience in teaching and excel in this area of statistical research. I count myself extremely lucky to have known him, to have learned from him, and to have had an award named after him. Dr. Catholi was a scholar whose kindness, intellect, and generosity will be remembered by all of us who had the honor to know him.
So I want to take a moment to discuss the Catholi Endowed Scholarship in Biostatistics. But before I do that, I just want to promise I didn't copy this off of Hong's statement, but I just want to say that I was lucky enough to meet Chuck Catholi in 2006 when I first joined the department as a postdoc. At that time, I was very impressionable and a little intimidated by the brilliant people that surrounded me. But Chuck immediately welcomed me and was genuinely interested in the work I did for my dissertation. He was especially curious when I told him about a derivation that gave me trouble and that I never figured out. For those of you who knew him, and for Hong, who can attest to this, it should come as no surprise that he asked me to share it with him so he could take a look at it and see if he could crack it. He was brilliant, but he was so much more than a fellow mathematically inclined researcher. He was genuinely interested in me, in my development, how I was adjusting to the academic life, how I was adjusting to teaching, adjusting to Birmingham, how Leandra, my wife, was doing, curious about the latest adventures with our dog. We had lunch together on many occasions over the years and talked about everything under the sun, including quite a few animated conversations about politics and UAB bureaucracy. But more recently, with changes in my professional responsibilities, he was always there to listen to me and give me advice. He taught me how to be a good academic, but also to look out for people and how to care. He was always teaching and ever humble. I'm grateful for every day that I knew him and recognize how fortunate I am to have that time we shared. I miss him terribly, and I know you do too. Last year, Charles and Ann Catholi gave an endowment to a scholarship named the Catholi Endowed Scholarship. This is separate from the Catholi Distinguished Dissertation Award. This was established to assist promising students pursuing graduate education in biostatistics, and we plan for the first award to be given out next year. This is one of only 2 endowed scholarships in the department, and we are very, very thankful to Chuck and Ann for their generosity. But I also want to emphasize that increasing the endowment leads to more awards and greater amounts of those awards. Many of you in the room have already donated to the Endowed Scholarship Fund, and I thank you very much for your donations. For those of you who would like to donate, please see me afterwards. I will let you know where the links are. We'll make sure that you have access to everything you need to know if you would like to make a donation. So please consider doing that, and we will share those details with you later. And with that, I'll turn it back over to Dr. Cofield.
Thank you, Jeff. So before we proceed with this, I will tell my one of my favorite Chuck stories. I have many. So I was born in 1973, so just after Chuck, yes, 73, just after Chuck started here at UAB, and George Howard, pictured here, was chair when I came to interview at UAB in May of 2003. And so if you remember from the timeline, that was right when Chuck became professor emeritus. So he had just become an emeritus professor, had just retired when I came to interview. And he picked me up from the airport. And I was the first new hire in a little while, and I was the first female hire, which is appropriate on a day like today with the Norwood Award. And so as you can imagine, a little bit of the red carpet had been laid out for my interview, and I was actually here, different from today. I was here for 2 days, 2 full days, and met with a lot of wonderful people. And Chuck picked me up from the airport and took me out to lunch. And later that evening at dinner at Hot and Hot, I believe, somebody said, well, where did you go for lunch? And I said, oh, he took me to Shoney's. If you're unfamiliar with Shoney's, think Cracker Barrel. And you know, the fright, right, was, you took this, and I was like, so I was 29 years old, and I thought, I looked at them and I said, are you kidding? I got to have the most nerve-wracking day of my life. I hadn't interviewed for a job in 10 years. I got to have a grilled cheese and bacon and a Dr. Pepper and talk to Eeyore for an hour. I was so comfortable walking into that interview after having an hour-long discussion with Chuck about UAB, about what the department was like, and about how excited they were to have me come interview and about the work that I had been doing and about having me join the department. That warm setup has stayed with me. So I also listened terribly, and now I'm going to continue before this just turns into a whole different type of talk. So it is my pleasure today to speak about the Charles R. Catholi Endowed Distinguished Dissertation Award. And because we're remembering Chuck, we thought we would go through the past awardees. These are the awardee recipients since 2008, and it's almost getting too large for a single slide. We are going to spend a little bit of time talking or just mentioning each awardee by name, because we do have photos of Chuck with most of the awardees. If you are here today and you see your name, please stand. And if your mentor is here, if they would also please stand while we go through the list of names. We would like to take a picture with all past awardees that are here today after the ceremony. So please hang around. We did not have a picture from 2008 or 2009. So I'll start with Tamika Jones and David Redden, who's in the background, and Scott Keith, David Allison from 2009. 2010, Hong Gao, who we heard from earlier. 2011, Nathan Weininger. 2012, John Bentley. Please stand, John, I know. 2013, Samantha Seals. Gigi Alban. 2014, Peng Li. Not here today. 2015, Brandon George. Can't believe I was here for all these people. 2016, Hwasun Kim. 2017, Yan Lee. 2018, Allison Fiakowski. 2019, Amanda Pendergraft. 2000, now we're into the COVID years, so we just have pictures. 2020, Justin Leach. Justin, for those of you that don't know, is now an assistant professor in the department. 2021, Ruba Shani. And 2022, Boyi Guo, who we heard from in the video, and 2023, Andrew Sims. And it is now my extreme pleasure to, with Jeff Sikowski, would you like to come up? Present the Charles R. Catholi Endowed Distinguished Dissertation Award 2024 to Li Zhang. And her dissertation award was predictive modeling using clinical data and compositional microbiome data. And would you like to join us for a photo? And we'll do some. Congratulations.
Yes, congratulations.
And I will turn it over now to Dr. Charity Morton.
Good morning. Like many of you, I also have a Chuck story, but I'll save it for the reception because I know we could be here all day. And I do want to present the Norwood Award to you as well. Before I present this year's recipient to the award, I want to tell you a little bit about who Janet Norwood was and why we've honored her with this award since 2002. Janet L. Norwood was appointed to the U.S. Bureau of Labor Statistics by President Jimmy Carter in 1979, when she became the first female commissioner of the Bureau. She headed this agency for 13 years and served under 4 U.S. presidents. She testified 137 times before Congress. She held her ground against presidents, and she earned a reputation for being objective, methodical, and unflappable. She once said, "I believe strongly that an objective, scientifically created system of data is essential for a democracy to flourish." At the Bureau of Labor Statistics, she oversaw almost 3,000 employees. She championed them and encouraged them to conduct independent research, and she created what she called a cognitive laboratory within the Bureau. Janet Norwood embodied the principles of statistical science. She advocated for the use of social and behavioral science in defining economic indicators. She brought, oh, you know what? There's a picture of her. She brought the National Longitudinal Survey to the Bureau of Labor Statistics and developed the Quarterly Employment Cost Index. She also had a particular interest in the measurement of race in the US Census and the implications of undercounting racial and ethnic minorities. Janet Norwood was once quoted as saying, we are responsible for some of the most sensitive of the economic data. These data figure very prominently in most of the political debates, so it's extremely important that they be accurate and of high quality." She knew that as statisticians and biostatisticians, our work has the potential to change the world, and she understood the importance of objectivity and statistical rigor. Janet Norwood was a fellow of the American Statistical Association and an honorary fellow of the Royal Statistical Society. In 2015, she was inducted into the Department of Labor's Hall of Honor, and the conference center at the Bureau of Labor Statistics was renamed the Janet L. Norwood Conference and Training Center. She passed away in 2015 at the age of 91. The UAB Department of Biostatistics gives this award each year to not only recognize Dr. Norwood's achievements, but also to recognize the contribution of all women to the statistical sciences. I will now turn things over to Dr. Anastasia Hartzis, who would introduce this year's winner of the Janet L. Norwood Award.
Good morning. It is my pleasure to introduce the recipient of this year's Janet L. Norwood Award, Dr. Kim Ondo. Dr. Doe comes to us from the University of Texas MD Anderson Cancer Center, where she is the Electa Taylor Chair for Cancer Research. Dr. Doe received a PhD in statistics from Stanford University in 1990. She began her career as a research fellow at the Australian Bureau of Agriculture and Resource Economics before joining faculty at the Australian National University, the University of Canberra, Queensland University, and then Queensland Institute of Medical Research. She joined the faculty of the University of Texas MD Anderson Cancer Center in Houston, Texas in 1999 as an associate professor and then full professor in 2004. She served as the chair of the Department of Biostatistics from 2013 to 2020. And in addition to her endowed chair position, she is currently the director of Quantitative Sciences Program at the University of Texas Graduate School of Biomedical Sciences, in addition to her many other appointments at Texas A&M and Rice University. Dr. Doe's work in bootstrap resampling, methodology for the analysis of complex high-dimensional integrative proteomics, genomics, and microbiomics data, functional and imaging data, and computation statistics have been recognized internationally. And in particular, she has been a leader in developing analytic tools and techniques in high dimension and cancer data with applications in personalized medicine, cancer diagnosis, and early detection. Some of the types of cancer to benefit from her research include pancreatic, lung, and digestive tract. She has most recently led a team to develop a biomarker panel for risk assessment of lung cancer. She is a prolific author with over 280 publications and 3 books, and has been invited to speak and present seminars over 160 times. In addition to published dissemination of her work, she and her team have produced several open source software tools. In addition to her many research-related and collaborative roles, she has mentored and trained over 60 researchers, and this includes training researchers, mentoring students, and early career faculty. Many of her trainees have gone on to prestigious institutions and leadership roles themselves. We on the Janet Norwood Committee were particularly moved by the enthusiasm of her nominators, who were emphatic in their indicating her service and contributions to the field, and her encouragement of those that she mentors, and recruitment of trainees and faculty to her department. And as so many of us know, the significance of a steadfast mentor cannot be overstated. And we were particularly impressed by her local work with the ASA, promoting scholarship and student engagement within the Houston chapter. And it is, of course, meaningful to mentor those who are already progressing in the field, but encouraging a love of learning and statistics for those at the very start of their academic careers is an especially powerful demonstration of dedication to the field. We are not alone in recognizing Dr. Doe's contribution to research and statistics. Not only is she a fellow of the American Association for the Advancement of Science, the American Statistical Association, and the International Statistical Institute, she is a member of the Royal Statistical Society. Please join me in welcoming Dr. Doe.
I'm so fortunate to be here to hear and celebrate the life of Dr. Cathali together with you folks. And first, I'd like to congratulate Li Jiang for winning the dissertation award. And I feel very honored and grateful to receive the Janet Norwood Award for 2024. I would like to express my deepest gratitude to UAB, Dr. David Allison, and others who have established this award. I'd like to acknowledge Dr. Jihan Lee, who nominated me, Dr. Charity Morgan, and the selection committee for considering me worthy of this award. I'm delighted and humbled to join the 22 prior recipients who were each uniquely talented, dynamic, and passionate women in statistics and data science. I also want to thank my family, particularly my husband and son, for their generous and continuing support. I would like to dedicate this award to the memory of my parents, who showed me the meaning of hard work, humility, and decency. They set my moral compass high and showed me the power of perseverance while teaching me strength, independence, and service to others. Dr. Janet was a pioneer and an amazing inspiration. She was a facilitator and a translator who emphasized that researchers need to focus on the consistency of data and how to aggregate data. She took steps to establish a culture that embodies many key factors, such as a multidisciplinary future for scientific work, an open and transparently research environment, and that no one discipline should lock out the other, that we should replenish our education, and we need to dissolve boundaries for multidisciplinary research. So my talk today, I try to make it a story in pictures. So I'll just describe just a short description of my career path. So I was born in Saigon to a middle-class South Vietnamese family. My mother was trained as a tailor. My father worked for the South Vietnamese Department of Foreign Affairs and was a diplomat to several countries. But my family's favorite post was his assignment to New Delhi, India, between 1969 to 73, where we had a wonderful life and learned a lot of how to assimilate into different cultures. Being sent, I changed from a French school to an English school overnight, and we learned to adapt to different schools. My parents never checked with us whether we wanted to go to any specific schools. They said, you are going to change to English schools, and that is it. So it was a very nice decision. because later on, my family was stuck in Saigon for 3 years when we lost South Vietnam to the communist regime on April 30th, 1975. So my father ended up being in concentration camps for working and being friends with the US government. In 1978, he was released from the camp, and my mother organized for my father and me to escape as both people, as refugees, to, we floated in the oceans heading towards who knows where, because we didn't know where we were going. We just wanted to get out of Vietnam, away from communism for our future. And so we ended up in the camps in Malaysia. And from there, we were interviewed by United Nations and other countries that were, in those days, happy to resettle Vietnamese boat people. Australia interviewed and accepted us as permanent residents. So Australia became my second home country where we were safe. My father and I worked, studied, and built our new lives. My father worked as a laborer in Australia while supporting me. I was lucky to receive free education from the University of Queensland. I studied full-time while working many part-time jobs, such as grape picking, working in a pineapple cannery, working as a teaching assistant for the departments of mathematics and computer science, and also volunteering as an interpreter for new Vietnamese refugees who settled in Australia. Luckily, our whole family was reunited in Brisbane 5 years later through the Australian Family Reunion Program. At the same time, I was lucky enough to get scholarships to US universities. So my early mentors, before I talk about the US, I want to talk about my early mentors from Australia, where I did my undergraduate in statistics and computer science. My first mentor was the Professor Jeff McLaughlin at the University of Queensland, who got me interested in computational statistics, mixture models, and the EM algorithm. We have had a lifelong collaboration in data mining, statistical analysis of gene expression data and medical statistics. And we even wrote a book together on gene expression microarrays. While I was there, a female faculty, Professor Helen McGilvray at the University of Queensland, her work was mostly focusing on teaching and curricular design across multiple disciplines. But she was the main mentor who encouraged me to apply for summer vacation scholarships at many Australian universities and to be fearless. It is her prompting that gave me the courage to spread my wings and applying to the UK and the US for PhD scholarships. She herself told me that she was stuck in Australia because she didn't do those things. So she encouraged the younger generation to do that, to escape Australia, to try new things. And through the summer vacation scholarship at the Australian National University, I also met Professor Sue Wilson, the only female faculty in the Institute of Advanced Studies, who advised me that there are many paths to completing a PhD. Most of the male faculty were working on theoretical methodology, but she said that's not the only path through probability and theoretical statistics, because her work was mostly on genetics and medical statistics. So later on, I met Professor Peter Hall, and I can talk about him a bit later because he was really my postdoc professor after I returned from Stanford. So I was one of the few students in Australia who applied to US universities for scholarships. And I was lucky to be admitted to Stanford, Berkeley, Yale, Princeton, Harvard, and Iowa State. And I didn't know anything about US universities. I chose Stanford because it has the same climate as Brisbane, and it's also got a direct flight between Brisbane and California. So when I got to Stanford, I was very scared. It was the first time I lived away from home in a new country with no family around. And there were no female faculty at Stanford. But I managed to find some very good mentors. The Professor Herb Solomon was the chair of the department, and he was like a grandfatherly figure, sort of like Dr. Kothali, you know. And I learned geometric probability from Herb, and over one of the summer, I wrote a simulation program, and then the next thing it was published. And Herb made it so easy that I said, okay, I would love to work with you. And I just want to get a Stanford PhD. But I will forever remember what he said. A PhD only opens the first door to your career. It doesn't matter which famous university you get your PhD from. What matters is what you can really do 5 years after your PhD. I didn't finish my PhD in 4 years because I was having a great time at Stanford. I was free, I was having a wild time doing ballroom dancing and skipping classes. And so I said, well, I want to do something sort of sexy. I want to do like computational statistics. And I actually didn't stick with her. I changed my topic a few times. But finally, I had Professor Jerry Friedman, who played a leading role in putting statistics at the service of machine learning and data mining. He became my final supervisor. But I learned to be independent and ask the right questions in a consulting project. And I learned to invent and implement innovative methods to find new ways to analyze ever larger and more complex data sets. So my first experience with Jerry was working on his dirty Fortran program, implementing classification and regression trees. So I still have this program today, even though now it's become more of a business tool that that everyone uses in the medical world. Now, Stanford was very different from Australia. It was a place where we felt that you either sink or swim. But I didn't have really close supervision like what I would have had from Australia, but I seeked out people. So the two people that I used to lament to were Professors Ian Johnston and Art Owen, and they were more like my non-academic mentors, and they were closer to my age, and they supported me through my emotional outbursts of imposter syndrome. How did I get here? I don't deserve to be at Stanford. But they assured me that they went through the similar feelings as well. But the kindest mentor at Stanford was actually Professor Byron Brown. He was based at the medical school, and I was learning how to do consulting. I came from a methodology background, but the medical school at Stanford was where it introduced me to real consulting projects in medicine. And Dr. Brown was instrumental in helping me to obtain my first faculty position at the Bowman Gray School of Medicine, Wake Forest University. So what happened was I didn't finish my thesis in 4 years. So I had to get a job. You know, I was a foreign student with a work, have to find somewhere that gives me a working visa. And Dr. Brown connected me with the Bowman Gray School of Medicine, where I met, where I found my true calling as a biostatistician, working with the nicest and most fun-loving biostatisticians and epidemiologists. So you know Dr. Kurt Furberg, Mark Espelin, and Ann Boyle, and of course, your Dr. George Howard and Virginia Howard. That was where I found that, okay, you can be, you know, you don't need to be a methodology biostatisticians. I learned how to review a protocol and work as a biostatistician on large, important, nationally funded health projects and clinical trials. The biostatisticians were friendly. They're real human beings. They showed me that you can have dual careers and still be very productive researchers. So that Wake Forest saved me. I survived Stanford, but Wake Forest University really introduced me to a new life. And that's where I found my calling as a biostatistician. But I didn't stay for long, mainly because I was really missing my family. So I was, my family stayed in Australia, so I was just always going back and forth between the US and Australia. I went back to Australia for 10 years, met my husband, and hung around with my family. My baby was born in Australia, but I was always pining to go back to the US. I worked for 3 years with Peter Hall at the Australian National University, and I worked for faculty positions at the University of Canberra, Queensland University of Technology, University of Queensland, and Queensland Institute of Medical Research. But I was always frustrated that Australia did not have the departments of biostatistics as in the US. So I moved to the University of Texas MD Anderson Cancer Center in 1999 at the calling of Dr. John Mendelsohn. He was the third president at MD Anderson. He strengthened the institution's focus on research-driven patient care, and he built a strong, innovative research program that emphasized the translation of scientific findings to improve patient care and prevention strategies. One of his goals was to build a top-ranked biostatistics department at the institution. So when I met him during my interview, Dr. Mendelsohn stated that MD Anderson could not be a #1 cancer institution without a #1 biostatistics department. So that was enough for me to leave all my family behind and pulled my husband and son and joined MD Anderson, hoping to pioneer a biostatistics department. So Dr. Mendelsohn worked closely with Dr. Margaret Kripke, who was an immunologist and executive vice president and chief academic officer at MD Anderson. She was known for her advocacy for promotion of women in academic medicine and science. And she was also my first mentor at the institution, my first non-statistician mentor. So my decision to come to Houston was enriched by the influence of 2 professors from Rice University, because now I have a husband. I have a tag-along husband. Now he's have his own expertise in parallel computing, but Rice University and MD Anderson worked together to recruit us. So my husband, Dr. Bradley Broom, is a computer scientist with expertise in distributed systems and parallel computing. So Professor Ken Kennedy and David Scott at Rice jointly met him, and he also got an offer at the same time when I got an offer at MD Anderson. So that was how we managed to get back into the US through Texas. Of course, we never knew what Texas was. We thought Texas was just a wild west. And but that was the first time we could get jobs together, the jobs where we didn't feel that we had to sacrifice for each other. And at MD Anderson, I had many friends. Dr. Jack Lee, Dr. Stu Zimmerman was the chair of biomathematics who recruited me for the new department. They also recruited the founding chair, Dr. Don Berry, together we built the Department of Biostatistics and Applied Mathematics. And he also recruited the best Bayesian statisticians to MD Anderson. So I made many collaborators, really wonderful researchers there. I ended up working with Chris Logothetis in GU department for 25 years on the SPORE grant. Margaret Kripke was the person that in my first week, I wrote a statistics section for her in 4 hours, and we got an early detection research network. So from then on, she introduced everyone in her department to work with me for all the grants. It was a wonderful, friendly place. We also had connections with Marina Vanucci, Bunny Malik, the Bayesian friends at Rice University, and Sanjay Shetty and Stu Tucker are my local friends who have, we are rock solid friends through thick and through thin at MD Anderson. And they also epitomize humility, and they are true believers of multidisciplinary and collaborative research. But right now, I have my current network involves just really wonderful, what I call the F4, fabulous, fun, fantastic friends. They're fearless women in statistics, data science, and community service, not through just research, but through mentoring and philanthropy. These are the data science women, and many of them have also received previous Norwood awards. So I'm comfortable with these friends. And also a couple of them I want to mention, they don't necessarily have to collaborate with me on research. They don't necessarily have to be quantitative scientists even. I befriend and admire passionate women such as Lynn Nguyen at MD Anderson. She is working at MDA to reduce cancer health disparities by increasing participation of minorities and women in cancer clinical trials and through community engaged collaborative research. And Silito Reyes-Gibby is an established symptom researcher with training in epidemiology and survey research, but she has the Provost Distinguished Faculty Mentor Award and has a very creative idea of mass mentoring for her philanthropic efforts. So these are the women that I connect with. I can pick up the phone and share my joys and sorrows with Jihan Lee whenever the SPORE grant doesn't get funded, or when there are unfair reviewers' comments on the biostatistics score. And Jihan actually encouraged me to contribute energy and efforts to the caucus Women in Statistics and ASA activities. She opened my eyes outside of research to be doing more community work. I started organizing iBright conferences and workshops at MD Anderson, and I had help from Shi-Hong Lin, Christina Kenzowski, and Marina Bonucci. And most of the time at conferences, I could talk to Sally Morton, Marie Davidian, Francesca, but I also have wonderful support from the faculty in biostatistics. These are the ones, we have more than 20 people, faculty between 2012 and 2020. Out of these, I actually increased the recruitment of women during those 7 years. So I was able to recruit Min Jin Ha, Suyu Lu, Christine Peterson, and Nabeha Tayop as 4 new faculty into my department. We also have not just because we are an MD Anderson a huge cancer center, we also need a lot of work with career biostatisticians and analysts, including quantitative research computing group. So I really appreciate the support of all of these people. So my vision of when I became department chair was I really wanted to develop and lead the Department of Biostatistics as a nationally and internationally recognized and well-funded program, where I realized that the omic world was multiplying, and I wanted to be able, our department to be able to translate genomic knowledge and technology to bridge the gaps between biostatistics, bioinformatics, computing, and to be able to apply a methodology to biology, clinical medicine, and public health, with the general goal that all our work should benefit our patients and society at large. So my goal specifically was to develop a well-rounded department that is world famous for research in novel methodology and collaborative endeavors, and also for training the next generation of data scientists, including postdoc fellows, graduate students, and analysts. So we can't do everything, so I had to focus on new areas of research. When I came to MD Anderson, and with Don Berry as the previous chair, he's built up on a very strong, innovative clinical trial design and analysis, and we've got a good group of behavioral and social statistics. But my focus was on building strengths in integrative analysis of multi-platform genomic and other high-dimensional data. And we recruited Ziding Fang from Seattle, so we wanted to expand on early cancer detection, statistical and data coordinating center. And we also recruited Hong Tu Ju from UNC Chapel Hill, that we wanted to expand in the imaging statistics and integrating that with omic. So all my work at MD Anderson also is motivated by the Moonshot program. So the Moonshot program was actually was introduced to us by the second president after John Mendelsohn, which is Dr. Ron DePino. And the initiative was that it should be a goal-oriented, milestone-driven. And he wanted to focus on building a comprehensive and full care continuum of cancer prevention for early detection, treatment, and survivorship. So this was also supported by the Vice President Joe Biden, who had a meeting in 2016 and conferred with cancer researchers in Philadelphia, sharing his first high-level meeting since adopting the cause of curing the disease on his personal mission. So Vice President Joe Biden then declared that he would like to clear away bureaucratic hurdles and make way for a moonshot to hasten a cure for cancer. So as statisticians, we realized that there will be a tsunami of data that involves all kinds of omic data coming to us. We want to be able to work in methodology and develop computational tools to see how we can integrate the different types of omics. So genomics, proteomics, transcriptomics, immunomics, metabolomics. But these data can come from mouse models or cell lines or human. So we are thinking of integration. It's integration across the platforms, integration across the different types of experiments. So so the motivation to integrate the different data platforms is that if we just work on the genome on its own, and then it is actually a relatively poor source of explanation for the differences between cells or between people. And that if we want to do proper clinical management of cancer and other complex diseases, it can be substantially improved by integrative approaches. The distinct data types provide different and partly independent and complementary views on most complex disease-related questions. So we want to be able to incorporate biological complexity, which actually requires multidimensional and multi-system analysis. And we really need to be able to appreciate the context of the biological analysis. To implement many of these ideas, we also organize different kinds of workshops to bring together scientists from different areas. So Don Barry used to organize the Bayesian Biostats conferences. And then when I became department chair, I organized the integrative biostatistics, genomics, and imaging workshops. So most of these workshops want to be able to incorporate and integrate data into our models. Now, this is actually a picture that represents a biostatistician's perspective of how you can integrate the different omics. So we usually want to be able to build a model with an outcome. A clinical outcome could be response to therapy, or could be survival, whether it's short survival or long survival, or you can have different modalities of imaging. And your x-axis could be multidimensional data, which represents methylation or microRNAs or genomics or transcriptomics. And we want to be able to build a network of a causal network between these different omic factors and linking it into the clinical outcome. So we need to develop frameworks to model the mechanism and clinical outcomes and assess within and between platform interactions. So I'm just going to share with you some of the work I've done. I'm not going to get too much into details of each one, because this is like, as I say, a whole odyssey through this jungle. But I think some of the few that have been used and could be shared with the proper user-friendly tools. The first one was working with Veera Baladanda Yuthapani, who's now the chair at Michigan. And usually I work with a younger faculty, and we would jointly supervise a postdoc. So the first thing we try to do here is an integrative Bayesian analysis of genomic data. So we develop an integrative Bayesian analysis model to address the challenges of multidimensional data. So the main advantages of this model can be summarized in 2 steps. Our model uses a hierarchical approach to model the fundamental biological relationships underlying molecular features obtained by different platforms. Secondly, it accounts for both the influences of different platforms and the biological relationships among the platforms in one unified model to predict patients' clinical outcomes. It can conduct high-dimensional variable selection, which adapts to analyzing hundreds of distinct molecular entity effects jointly in one model. It uses a Bayesian framework, which allows the model enough flexibility to estimate the different intrinsic structures of biological relationships for different high throughput platforms. And finally, it is also computationally efficient and feasible due to the closed forms of the full conditional posterior distributions for posterior sampling. So in summary, the mechanistic model that we present here regresses the measure of gene expression on the kth gene, for the kth gene, on the methylation measures obtained within the promoter of the kth gene. So to match the methylation sites to a given gene, we use the annotation files for the platforms and employ those methylation sites that are encompassed within the promoter region of a given gene. So the second component of our model assesses when the expression of a particular gene affects the clinical outcome, whether this effect is modulated through methylation or through some other mechanisms that are independent of methylation. So with this tool, we've been able to build and share the tool so that we can use this for everyday analyses when you have both methylation and gene expression data together on patients. Now, the next, when you have so many omics platforms, you can't really throw all of them together. So we start doing it pairwise, 2 at a time. So the IBAC was able to handle gene expression and methylation data. So we also wrote, the next paper we wrote was on integrating gene expression with microarray RNA and linking it with clinical outcome. And once again, this is something that I work with another junior faculty, Francesco Stingo, and we supervise a postdoc, Thierry Shoko. So our approach here incorporates gene and microRNA interactions via a novel variable selection prior. So we hypothesize that a gene that's regulated by many microRNAs is more likely to affect clinical outcomes. So similarly, the selection of microRNAs depends positively on the corresponding number of target genes. So the miRNA regulator network can be built on using some kind of novel graphical model approach. And Francesco Stingo worked with Marina Vanucci in his postdoc on a graphical model, which we were able to apply to this setting. So we can account for the down regulation constraints of microRNAs on target genes by imposing a generalized gamma distribution on the regression coefficients that define the regulatory network. And we can depict our proposed model formulation as a Bayesian hierarchical model that includes the selection of the microRNAs and mRNAs, prior distributions that incorporate biological knowledge, and microRNA regulatory networks that capture structural dependencies among the biomarkers. So once again, our model consists of 2 main levels. Given a set of candidate targets and pathway information, the first level aims to identify a microRNA regulatory network based on both experimental and expression data. And the second level aims to identify a set of significant genes and microRNAs that are associated with survival time. So now this tool is also used regularly by, we have applied it to the cancer genome atlas for kidney cancer. But it can also be used for other cancers when you have both gene expression and microRNAs, and you want to be able to build networks between these two platforms. So those were like the early days when we were just dealing with just gene expression and methylation and microRNAs. But we've extended more to proteomics, transcriptomics, and spatial transcriptomics. And so I've decided that we've got a group of people, we are computational statistics, but we are hiring more people and working with different focus groups and proteomics. So we have a website here. COSMIC stands for Computational Statistics, Medicine, and Integrative Methods for Cancer. So if you're interested in following up some of our work, if you can, we have lots of computational tools that we share. And this is the group that I'm working and meeting every week. Since I stepped down from being department chair in 2020, this is sort of like my family, my fun Tuesdays when we come together and work on research and discuss problems and thinking of new ways how to develop patient-driven statistical models. So we do both theory and methods, applications, and we have education and goals. I don't have to administer or work on administration with 200 people anymore. I just have my little group of 20 people. And so I can talk more in details about the work that we have developed for proteomics and microbiomics. So this work is also done jointly with Vera, Baladanda Yuthapani, and we supervise a postdoc, Minjin Ha. But Minjin Ha now has gone back to Korea and she's got her faculty position. She also got an RO3 award for this work, and it's called Personalized Integrated Network Modeling of the Cancer Genome Atlas. It is a pan-cancer study, and in response to precision oncology, where we try to use approaches to cancer treatment that seeks to identify elective therapeutic strategies for every patient. The aim of our model is that we want to develop a general framework that conflates both global and local approaches. So personalized cancer specific integrated network estimation, that's what PRECISE stands for. We use this framework to analyze the interplay of proteins in signaling pathways in various cancer types, and also infer patient-specific pathway activities. PRECISE is a multi-scale approach that integrates multi-sources of information, including existing protein-protein interaction databases, data-driven de novo causal structures, and diverse molecular profiling data at the transcriptomic, epigenomic, and microRNA expression levels. So our PRECISE model outputs cancer-specific integrated networks, infers patient-specific networks, and also elicits interpretable pathway-level signatures by summarizing the patient-specific network as a single score that can be used for tumor stratification as well as prediction in as well as prediction in cohorts of patients. So while pathways have often been assessed at the DNA and RNA levels, proteomic signal networks are emerging as critically important for two reasons. The amount and function of proteins are integrated to initiate changes that occur at the genomic and transcriptomic levels, and predictions of protein levels from RNA levels are weak due to post-transcriptional and translational effects. And so secondly, the signaling properties of proteins can be further modified post-translationally through phosphorylation and other processes, which cannot be predicted at the genomic or transcriptomic level. So as proof of principle, we apply a precise method to a pan-cancer reverse phase protein array of 7,714 samples from 32 tumor types, this from the Cancer Genome Atlas. So our analysis focuses on these 12 pathways because it provides a refined picture of the shared or unique structure of cancer-specific proteomic networks and pathway-based signatures that classify the subtypes represented in the pan-cancer data and predict the patient outcomes. So this is a general graphical presentation of our model. So PRECISE, in summary, uses a multi-scale approach. The implementation of our model on proteomic networks requires two inputs: data, which is proteomic data and other upstream molecular profiles, such as gene expression, microRNA expression, DNA methylation, and prior information, including known pathway annotations and protein-protein interactions from existing databases. So in the first step of PRECISE, a data-driven protein causal network is estimated and combined with the prior information. The other upstream molecular data are then integrated in 3 sequential steps to produce cancer-specific, patient-specific networks and pathway scores, which are subsequently used for tumor subtypes, classification, and clinical outcome prediction. So we use a Bayesian regression model in which each protein is regressed on covariates that includes the protein regulators learned from the data-driven causal networks and the protein-protein interactions as prior information and features from upstream data. The selected regulators for protein constitute the population-level cancer-specific integrated network. So given the population-level cancer type-specific network, we can deconvolve the patient-specific PRECISE scores using the status of each protein or node of the networks, and we can define them as suppressed, neutral, or activated. And we could use these PRECISE scores for patient stratification and clinical outcome prediction. So those are the statistical nitty-gritty details that we have done. But when we work, we can rewire the protein signal pathways in cancer. We can investigate the cancer-specific integrated networks by reducing, presenting the data as pathway activity or edge consistency. So our major findings in brief can be represented by tables and pictures. So For this table, we find that there was a high degree of variation in pathway activity across all cancer types, with some signaling pathways showing higher connectivity in certain tumor types than others. We suggest that the data-driven cancer-specific network aligns well with a priori functional characterizations of the pathways. We also use network-based tumor stratification using the precise scores that we hypothesize that the core signaling pathways tend to act in the same direction for patients with the same tumor origin. So to identify subtypes of the cancer patients and pathway determinants of those subtypes, we actually developed a tumor stratification algorithm for all of the tumor samples in the 32 lineages based on the precise scores. So the precise scores were computed by deriving summary measures from the networks, from the patient-specific networks, and indicating that the entire pathway can be suppressed, neutral, or activated. And for the clustering analysis, we combine the suppressed and activated scores by summation. And after matching all the 4 platforms, RPPA, mRNA, expression, microRNA, and DNA methylation, we actually have a large matrix of 6,844 by 12 suppressed and activated precise score matrix. So this matrix was the input for our clustering analysis, and it identified 23 optimal clusters represented, by the top part. And we found a high degree of concordance between the precise clusters and tumor types, suggesting that the intrinsic pathway activity patterns in the given lineage are key drivers of the precise scores. So when we're working with biologists, we always end up having to provide results through pictures, and we summarize a lot of our statistical work through, for example, the radar plot that shows the different activation of the different pathways. And I'm going to just mention a little bit about human microbiome in the interest of time. So I wouldn't have to, we worked actually, I realized that beside omics, we were moving more into multidisciplinary work with the human microbiomes. So we work with Jim Allison, who's the Nobel Prize winner for immunotherapy. But the question is microbiome the deciding factor for immunotherapy success? So I focused on recruiting Christine Peterson and a couple more postdocs to work on with the infectious disease group and Jim Allison in developing methods for microbiome. So I wouldn't have time to talk about all the detailed work we've done, but we started out working on reassessing the methods that the microbiologists worked with, and many of them, they use existing methods without really considering the complex correlation structures between the microbiome taxonomy. So this is our team where we developed new methodology incorporating the complex correlations, the phylogenetic trees, and I'll have to come back and give another lecture sometimes to share this. So I'll just end up with showing you this list. If you are getting into microbiome analysis, So we spent the last 5 years working and developing new methods, and we have tools. So I'm quite happy to share anything that I've done in terms of tools for microbiome analyses. And this is still ongoing. I'd like to acknowledge a lot of funding from NIH, from local secrets and moonshot support for the work by our group and with our collaborators. Acknowledge these are my current strong collaborators. We will be moving more into spatial transcriptomic and looking at statistical and machine learning methods. It is a wonderful time for data science and statistics. And I will end here with some concluding remarks and quotes that resonate with me as I look back on my career. I'd like to quote Melinda French Gates, that there is so much potential in everybody, and we need to unlock that potential, break down the barriers and the biases. And Michelle Obama, I really resonate with being open to people, invite people into your lives, be open to all the possibilities. But right now, finally, at this stage in my life, I really want to be able to sit in the park and observe people. I don't want to lose my anonymity. And I'm just so happy to join you for this celebration. And once again, thank you for joining me today.
Thank you so much. So it is my pleasure as the chair of the Norwood Committee to present you with the award.
Thank you.
Yeah, and then also, Gian, your nominator and friend,
Yes.
sent flowers. So she
Oh,
couldn't be
thank
here
you very
today.
much.